So, having looked at the derivation of the expression for determination of refractive index of a liquid and basically a small amount of liquid for a concave mirror, now let's look at how do we now carry an experiment to determine the refractive index. I will start by having some simple drawing here. If that is my concave mirror, and then I have my liquid there, I can draw some simple thing here to represent my retort stand. This is my retort stand, and then I can have this, and then this one should be my principal axis. So if this is my object, this is the image, and I can surely say if this height is now H, okay, this is our test liquid, and then this is my concave mirror, and then this is a retort stand with a clamp. This is our image, and this is our object. Okay? And I've drawn that line to represent the principal axis of our concave mirror. So, what do you do first? In doing this, number one, you are supposed to place a concave mirror on a horizontal table with its reflecting surface facing upward. Okay? So number one is you should get your concave mirror, place it on a horizontal table, make sure that the reflecting surface is facing upward. So after doing that, you're supposed now to clamp a pin on a retort stand and hold it vertically above the what? Above the concave mirror. But very important in this that I should mention is with the tips lying along the principal axis of the mirror. This is again what is very important that you should not fail to mention, with the tips lying along the principal axis of the mirror. Because now if you have not talked about that, it means that in your method there is a possibility of parallax happening, isn't it? So for non-parallax method, we ensure that the tips of the pin is along the principal axis, okay? So you should ensure that. And then we can now add by saying move the pin up and down to locate a point where the object coincides with its image by no parallax method. Okay? So now, after getting your concave mirror, placed it on the table, you have clamped the pin, and we're saying that in the process of the clamping, make sure that the tip of the pin is along the principal axis, or the center of the what? The center of the concave mirror. And then what you do next is keep moving it up and down as you are viewing from above. Okay? As you're moving it, you'll be viewing from above. That you'll see the image coming and going away, coming and going. And make sure that you identify a point where the object and the pin, they are just coinciding like this by non-parallax. They should not be like this. You see them in same line, but like this. This is what they're calling parallax. And it always happens when you disobey this statement here. When you make your arrangement and you find that the tip of the pin, instead of it lying at the center, it is aside. So always whenever you remove it, you see the image and the object, they will be parallel, or what we're calling the parallax idea. So you should ensure that there is no parallax, and by doing it, what we have just underlined there. So move it up and down until it is seen to be coinciding there. And then you can say, yeah, I can add there as viewed from above. Okay? So you'll be viewing it from above, what we are talking about. We shall say measure and record the distance from the pole as r centimeter. So after that happening, measure and record the distance as r, and that is the radius of curvature. Remember where we have reached so far is an experiment of determining the radius of curvature of a concave mirror. Where you say what you do, move a pin up and down, and you say in a scenario where the object and the pin are all at the same point, it means light rays that is coming from the object is striking the mirror at the same point, and therefore it is moving along the same path. That's why the object and the image are all at the same point. And we say in a scenario where the reflected ray is normal or makes an angle of 90 with this surface here, if the reflected is now stretched back, the point where it cuts the principal axis is the center of curvature, and the distance from the pole up to that point is the radius of curvature. And that is where we are getting the idea of saying that the point where that is happening is radius of curvature. So that is establishing the radius of curvature of the mirror first. And then in the next step, after identifying that, you can say now a liquid whose refractive index is to be determined is now added in the concave mirror to a depth of say d centimeter. Okay, Again, now after adding that, okay, you are now supposed move the pin up and down to locate again the point where the object and the image coincide by no parallax. By no parallax method as viewed from above. Okay, so after putting smaller liquid here, move it up and down again. Make sure that the image, because the image will come as anaconda. If the pin is here, the image will come the other side. You'll see it as you're moving, coming and going, but adjust not until the tip is just coinciding like this. No parallax. That means they should not be moving parallel to one another. Okay, they should move in the same line. So, having done that, you are now supposed to measure and record the distance from the pole to the point of coincidence as the h centimeters, and then you can say refractive index of the liquid is then given by any L equaling to R minus D out of H minus D. And that is when our H is measured from the pole. For someone who says measure the distance from the surface of the liquid as H, you're supposed to say R minus D out of H. But if I measure it right away from the pole here as per my diagram, the refractive index is supposed to be this. So please, you should be noting the marking point when we say by no parallax method. Okay? We talk about the no parallax method where they coincide. Okay? Object coincide with the image by no parallax method, and then add liquid, move up and down. Yeah? Again, you talk about this, measure and record the distance. So if you talk about that, you would have described the experiment for determining the refractive index of a liquid of a smaller quantity of a liquid using a concave mirror.